Hi there, welcome to today's lesson. So today's machine learning lesson will be on how to use Python for classification problems. Classification models are part of the supervised learning algorithms, and it basically involves taking some kind of input and mapping it to some discrete label. So for example, a classification model can take a bunch of human faces as input and determine whether an image is of a male or of a female. For today's classification problem, we'll focus on the iris dataset. The point of the project is to take a number of features from flowers and determine whether a flower belongs to any of these three classes over here: Iris setosa, Iris versicolor, and Iris virginica. The algorithm we'll be using for this presentation is a random forest classifier, since it is known for its robustness and its ability to find patterns. Now, a tidbit you can actually use is if you find yourself having structured data, it's more advisable to use ensemble methods. An ensemble method is where we use multiple algorithms to predict an outcome, like the way random forest uses multiple decision trees to predict an outcome. Awesome. So the first thing that we actually do is to import the necessary libraries that we'll actually need. We need pandas and numpy for data analysis, data manipulation, data cleaning. We need seaborn and matplotlib for data visualization. We need sklearn for machine learning, and also importing the datasets that we need, like the iris dataset, which is inside the dataset module. We'll also import the train test split. I'll explain why we need this later. And then we import our random forest classifier, which is the algorithm that we'll use. Awesome. So we run the cell, and then the next thing we need to do is to actually import the dataset from sklearn, and that's the whole point of this line of code. We are saving the dataset in iris. All right, we can check out the dataset, and we can see that the features over here have been separated from the target itself over here. And setosa is 0, versicolor 1, virginica is 2. Awesome. The next step now is to save this iris dataset as a pandas data frame, and that's the whole point of this line of code over here. So numpy.concatenate will combine the features and the independent variables and dependent variables, and finally pd.dataframe is going to create a data frame from that. And if we do a .head, we see that now it has created a good data frame with all the information that we actually need. Next. Awesome. Now we can be able to run pandas attributes, pandas functions on the iris data frame itself. As you can see, if you run a .shape, we see that we have 150 observations and we have 5 columns. Awesome. We can check for missing values. We don't necessarily have any missing values. Check for duplicates and sort the duplicates by dropping them, making sure that they've been dropped. I don't want us to get too much into the cleaning because the whole point of this lesson is building the model. So how do we go into building the model itself? The first step is to assign input and output variables. So basically separating dependent and independent variables into x and y. So x will have the independent variables, the 4 independent variables: sepal length, sepal width, petal length, and petal width. And then y will have the target variable itself. And if we separate them, look at x, it has the 4 independent variables, and y has a target variable. Awesome. The next step that we actually need to do to split the data into train sets and test sets. The whole point of this is so that we can run our machine learning model on the training set and train it on the training set, and then have it and then test the performance of our machine learning model on our test set. All right, that's the whole point of that. So we split the data into training set and test set, and the test set is 20%, so the training set is at 80%. That's the whole point of this piece of code over here. And then the next step that we actually need to do is to train our model now. Yeah, now that we've split our data, we now train the model on the data itself. So we instantiate the random forest classifier as RFC, and then we use it to fit our data and train our model. That's the whole point of that. And then over here we evaluate our model. We see that we have an 86% accuracy. It's not too bad. We can now check using a confusion matrix to see how our model performed, where our model performed well and where our model actually performed poorly. And we do visualize our matrix. We see that it predicted 2 observations over here wrong and another 2 observations over here wrong, but it predicted 9 observations correctly as class 0, 7 correctly as class 1, and 9 correctly as class 2, meaning that our machine learning model has performed fairly well, not too bad, especially just looking at the accuracy itself. So that was a basic introduction into classification with Python. Thank you very much.